there is an important difference between an operation with a value that cannot be represented in the type of the expression and an assignment where we cannot represent the value in the type of the variable. Okay, so what does that mean? It says that every operation is performed with the type, and the type of the expression is the biggest type, so to speak, of the operands. So if you have an int and a double, the type will be double. This is in the standard called the rank of the type. Okay, and car has a lower rank than short, etc. So they are converted to a common rank, and then this operation has that type. So, and this one is dangerous, can be, or actually it is dangerous for different reasons. It's undefined behavior if we have signed integer and an overflow. Overflow means we cannot represent it in the type, so okay. And it's defined, the behavior is defined for unsigned integers, but it may be completely buggy code, since the programmer perhaps did not expect the value to be so large. And the same for floating point. With essentially all modern machines, what happens is that the value will become infinity. Okay, so you can, and this comes from the current hardware standard about floating point numbers. Okay. So if we look at this instead, it's implementation defined. What will happen? So what happens? Well, the common thing is that we store as many bits as possible. So and the only thing that makes sense and that is used is to store the lower bits here. Okay, that means we lose information, but that's not significant. I mean, it's not undefined behavior. It's defined, so we can read the documentation. What will happen now? And okay, so what will happen? Well, for this, what will the values be? That's the question. Here we will have an unsigned car, so 8 bits, and we store 8 bits. I mean, to f. 1f is 4 bits, so the value will be 255. Here we store also 2 f's, so the value will be -1. And why -1? Well, we have seen this before, but we can just review it. And so it's the value of this is -128 plus 64 plus 32, etc. plus 1, which is -1. Okay, and here the value will be infinity. And infinity, that's a special bit representation of the exponent for a floating point number. Okay, and the same for this special number called not the number. It's also a special representation of the bits, not only the exponent, but at least some other bit will also need to be a non-zero. Okay, so let's have a quiz. What's the value of this? On campus lectures, the first answer usually is 0, and that's wrong. What happens? Well, what is the type? The type of 1, that's int, and the type of unsigned car, well, it is unsigned car. Of course, I mean the type of use, it's unsigned car. So this one is converted to an int. Since I said operands with the type smaller than int are converted to an int. Okay, so what we do is to add 255 in type int and 1 in type int, so the value is 256. Okay, what about this? What is the value of this? Well, anything can happen. Run away, because the computer can explode. This is undefined behavior. Okay, and if we instead have unsigned int with this, okay, I didn't say what it is, but it's the maximum integer that can be represented on this implementation, and the corresponding for unsigned int. Here the value is 0, since it wraps around, and for floating point it becomes infinite.